Welcome to our channel. In this session, we are moving to the program maximum depth of a binary tree. Coming to the question, given the root of a binary tree, you need to return it maximum depth. What is the formula they given? A binary tree maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. That means you need to start from the root node, find out the longest distance. So in that longest path, how many number of nodes are available? That is the maximum depth. Now here 3 is the root. 3 to 9. What is the maximum depth? 2. Maximum depth is here in terms of edges, only one edges, but in the question they are asking the number of nodes in the path. So in that path, 2 nodes are available. Here the depth is 2. Now 3 to 20, 3 to 50, 20 to 15. You need to reach the leaf node. Here, what is the maximum depth? 1, 2, 3. 3 to 20, 20 to 7. What is the depth? 3. So among this, the maximum value is 3. Now, so like this, if you have any question, for example, 1, 2, 3, 4, 5, 6, 7, 8. Now you need to identify the maximum depth. So 1 to 2, 2 to 3, 3 to 4. 5 nodes are involved for reaching 4. 1 to 5, 5 to 6. 3 nodes are involved. 1 to 5, 7, 6. 4 nodes are involved. The maximum depth is 5. Simple thing. 1, 2, 3. 1, 2, 3. Here you need to move from the root node to the leaf node. How do you identify? It's a very simple logic. So you need to use recursion. I am recursively moving to the left side. Assume this is stored in one variable L. So root dot left initially this is the root node. Yes or no? So L is equal to root dot left. This is the left side. Any left is there? Stop. Similarly, R is equal to root dot right. Here I am using recursion. I am moving to the right side, right side, right side. Finally, what is the value in L? What is the value in R? Whatever the maximum, you are considering that maximum value. You got the points? Very simple. Move to the left side, move to the right side. Which one has the maximum value? That is your final answer. Now, I will execute this one. Observe carefully. If not root, that means if there is no tree, if there is no tree, return 0. That is the maximum depth is 0. Otherwise, what I am doing? L is equal to max depth of. L is equal to max depth of root dot left. So here I am calling recursively. Observe what the value present in L. First time L is equal to max depth. This is the root. Root dot left. Root dot left. Okay. And in the next iteration, if any element is there, that is added. Now I am moving left to left to left to left to, and it stores L value. Similarly, I am have one more variable R is equal to self dot max depth of root dot right. I am moving to the right side. Now what consists of? L consists of the left side value. See this one? The left side value. R consists of the right side. Now finally you need to return maximum of left and right. Yes or no? I am using predefined function max of L comma R. But anyway you are not getting the answer. Why? If they are not asking the number of edges in the path, they are asking the number of nodes in that path. So plus 1. So two nodes are combined with one edge. Whatever the maximum value you are getting, for that you need to add one. Then only it gives the maximum number of nodes. See this one? Accepted? See, accepted. Check again. Suppose in this example, what happened? If not root, no, root is available. L is equal to max depth of root dot left. So what happened? This is initially root. In the next iteration, root dot left. This is the root. How many number of times you called? In the next time, for this there is no left. So it returns 0. Like that, max root moves to the right side. Root dot right and root dot left. This is the program of the maximum depth of a binary tree. Remember here they are follow edges and the question they are asking nodes. That is the reason I added +1 also. Thank you.